So next up, we'll have Dr. Tim Brown of the Desert Research Institute talking about the fire environment in the Southwest, climate, weather, people, and places.
All right, good. All right, thank you, Ben and Greg, and good morning, everyone. What I want to do here this morning is very tersely and succinctly connect climate, weather, and people and places with the ultimate idea of thinking of this in terms of planning and policy and where we're at with that. The Southwest, as you probably already know, is a very dry place. But as Don showed, it's still very diverse in vegetation. And even when it's not dry and it's wet, that helps that vegetation grow even more. And so if we think about the vegetation in terms of evapotranspiration, this is relevant because we want to be able to link the atmosphere to fuel moisture. And the fuel moisture is basically an indication of the flammability or the burnability of the fuel. So again, the Southwest here is a dry place from the evapotranspiration perspective. This is the annual reference, ET, for the 1981 to 2010 period. So a recent study by John Boxiglu and Park Williams looked at different indicators from a fire perspective largely. For example, this is energy release component, a fire weather index. This is actually Australian index. This is a fire drought index. This is evapotranspiration. But what this is change in fuel aridity over basically this 15-year period, 2000-2015. And what we see in these maps are what fire folks have been seeing on the ground, and that is a drying out of conditions. And it's been especially noticeable during the nighttime. And thinking about a planning perspective, it used to be that you could rely on the nighttime to do certain tactical actions because fire would tend to lay down, and that's more and more often not the case now. Don went into some detail on this. I just have this one quick slide that shows the area of tree mortality from bark beetles from 2000 to 2016. That's what it looks like in a picture form, but it's a very large area across the West. And of course, this is climate driven, and there may even be, to some extent, some drought influence in these areas. So to connect weather to fire, this is just looking at evaporative demand from the evaporative demand drought index, and it's made up of temperature, relative humidity, wind speed, and solar radiation. And all I mean to do with this is just show you, you can see the time up on top going through the days of 2017. All I want to do is show you how quickly the conditions can change. These bluer areas representing wet, the redder areas representing dry. And if you spend a little bit more time focusing on this, you can begin to correlate these red areas with significant fire activity that we had over this past season. So that's your one way to connect the weather to fire is through this evaporative demand. And of course, wind plays a role. Once an ignition has begun, wind is a primary driver, although terrain can be as well. You'll probably recall this year we had very extreme fire activity in October in Northern California, up here under the influence of these Diablo winds. And then in December, down in the LA area, was influenced by these Santa Ana winds. So basically in the West, I guess we could summarize this, is that the entire West is a place where there are lots of fire, and there always have been. But we'll have a new factor as part of this now that's come in over the years, and that'll be the people. And if we look at fire trend, Don showed something kind of similar. This is MTBS fires through 2011. The main thing here I just wanted to show is so you can see the area of the western U.S. that has fire. If you added fires since 2011, they would just be more red in a lot of these same places. The graphs on the right shows the number of large fires per ecoregion. And a large fire here meaning 1,000 acres or larger. And if we look at something, like the basin and range, which is going to be this tan area here, effectively not a lot of trend over this period going back to 1984. But if we look at the Arizona and New Mexico mountains down here, there appears to be a trend. The warm desert's a trend. Part of this is probably grass-driven. The Mediterranean California shows a downward trend, at least through 11, but we have had, again, some large fires in here. So if this were updated, this might look a little bit different. So lots of fire across the West. And for population, if you can see this, this is produced by the Silvas lab at the University of Wisconsin in Madison. The gray background, not sure how well it's coming through, but if you can see the red areas and these tan areas, this represents the wildland-urban interface, and basically areas where people are living in a place of which fire could happen or is known to happen. The interesting thing about this, of course, the eastern U.S. Looks the whole region is pretty much a wildland-urban interface. There are lots of fires back there. In fact, in terms of number of fires, there's more than there are out west. But the western environment with the vegetation type and the aridity and the climate variability makes it very susceptible to these very large fires and these very destructive fires. So what I want to do now, as I mentioned, this Santa Rosa fire took place in October. I want to give you some study report results. Fires were close together and burning concurrently, creating a major conflagration which taxed the capabilities of the fire services involved. They damaged or threatened urban and rural areas, and they induced several different fire suppression organizations to work together to achieve control. Well, that sounds about right. And those bullets were pulled from this 1964 report on the Santa Rosa fires. There's actually one more on here I didn't add that talked about nuclear explosion in the rural area moving into urban. Hopefully we don't have to think about that one. But the point about this is that these bullet statements very much apply today as they did over 50 years ago. And in fact, in this case, this red perimeter is the Hanley fire of 1964. The black perimeter is the Tubbs fire from 2017. It was a very, very destructive fire. And what was one of the main differences? Well, we can look at the housing units per square kilometer. Again, this red outline is the Tubbs perimeter. So here's 1940, and these orangey, the yellow is 0 to 10 units per square kilometer, and then the brighter, darker the orange, the higher the housing density. So if we just loop through this, here's 1960, here's 1980, and here's 2010. So what we're watching is people moving in to naturally fire-prone areas. And this is true for many places across the western U.S. And this is why it's so important that we need to think about the people as well as the physical components of fire. So a very quick history of fire policy in the U.S. The first major one really began in 1910. There were major fires, the big blow up here in northern Idaho. And that was when then Forest Service Chief Henry Graves issued a bulletin about protection of forests from fire, because burning forests, for the trees and the timber was considered an agricultural product, and hence why the U.S. Forest Service comes under the U.S. Department of Agriculture still today. And shortly after that, Congress passed this Weeks Act, which allowed the Forest Service to cooperate with states in fire protection. And this effectively created the first interagency wildfire fighting effort. Well, then time passed, years went by, and we had another major set of fires here in the Pacific Northwest and in the Northern Rockies. This was also about the same time that the Civilian Conservation Corps was established. And so one of their missions was to help prevent forest fires. And so suddenly now we had a big workforce to help with this. And so the 10 a.m. policy was adopted by the Forest Service, a very aggressive policy that if a forest fire was reported at 10 a.m. This morning, it needed to be put out by 10 a.m. tomorrow. And if that didn't work, 10 a.m. the next day, and so on. A very aggressive policy of which much still carries into today. But in 1971, and going back, notice these drought periods here. And I should say that drought has never been a upfront consideration when it comes to forest and wildfire management planning, but it has always been in the background. And likewise, so the wet periods, because in 1971, the suppression policy got modified to begin initiating more natural fire experiments. This has been ongoing in the Southeast all these years anyway, but this is the first time from a policy perspective it was becoming more adopted in the West. And then in 1994, in this major drought area, we had the South Canyon fire causing related to 14 firefighter fatalities. And this event led actually to the first comprehensive wildland fire policy, which got updated again in 95. And then the 2000s come along. We've had these numerous high impact fires. We've had these increasing climate and fire extremes. Tamara's going to be talking about the fire extremes a bit, the convergence of the climate, fuels, and people. We've seen changes in fire suppression tactical strategies. Major one is going from direct attack now to a lot of point protection, meaning that we're trying to protect values at risk that are very place-based. And Steve Pines talked a lot about this, so he's got some points here that I really like, that today we're seeing threats outpace responses. There's all this institutional competing and resources and requirements. And we have the development of a fire industrial complex. It's a big and very expensive system. And one more piece to this that we're seeing is the human health perspective. If you look at the proportion of population affected for different disease and health risks and the severity of the effect, you get this triangle where you tend to go hopefully to fewer cases from subclinical effects or subtle effects to mortality. But Pete Lom is thinking of this in terms of we're really going from thinking about wildfire smoke and wildfire from health to an actual public safety impact. So where are we at now? In 2009, the National Wildfire Cohesive Strategy was developed. I think the main points here is there's three major goals: to restore and maintain landscapes, the fire adapted communities, the wildfire response. But here's the challenge. The challenge is, so when you ask the question about where should wildfire management planning and policy go, these are the boxes that we need to think about. You know, the state of the vegetation and fuels in the homes and communities, the relationship to humans and ignitions, and the response we're going to have. There's lots of opportunities in this, both from agency and community, and even personal perspectives like home defense action, and adjusting building codes, but the role of prescribed fire and these sorts of things. And here's one example of the challenge. These are counties, and so the colors represent the darkest colors represent a high-risk area of wildfires, but less potential for resource benefits. So when you're fighting these fires, you want to have a policy that you're trying to benefit the resources, in that landscape, while also doing the kinds of protection for the values at risk that you want. And then we have other areas that are moderate risk of large fires, less potential, and so on. So from this map alone, you certainly get an idea of the large extent of the issue. So the summary thoughts here: climate enables fire and weather, or climate enables fire and weather as a driver. The warming and drying is a major factor, but fire is also defined by human geography. The key intersections that challenge fire planning and policy are the fire environment, the physical side, but it's also the fire management and practices. It's the population growth and development, and these areas of fire proneness. And if you ask the question, what are the effects of recent catastrophic fires on wildfire management planning and policy? Well, I very much agree with what Steve Pine says here. Fire management is a societal and political problem. It's not a technical or a scientific problem. And I think that's it. So back to you, Ben.
All right. Thanks, Tim.